So remember, our entire purpose for figuring out whether or not something was a binomial experiment was so that we could use some kind of quick formula to be able to find probabilities. And that's exactly what we're going to do. So if we have a binomial probability function, if our experiment fits the binomial criteria of fixed number of trials, independent trials, probability of success is consistent, and there's only two outcomes, then we're able to use our calculators to perform the calculations for us. In particular, we want to be able to use Binompdf, P as in probability distribution function, and CDF, which is standing for cumulative distribution function, if I'm not mistaken. All right, so which one we get to use and how we get to use it all depends on the terminology and the problem that we're trying to find. So wording is going to be very important to us because, for example, less than and at least are two completely different things. Less than uses CDF with x minus 1, and at least uses 1 minus the binomial CDF, but also with x minus 1. So we're just going to practice, for our first example, just deploying these particular rules with this problem with no context. And then we'll start adding in context with other examples, and that'll help explain why it is set up this way. Why fewer than uses x minus 1, but less than or equal to uses just plain x. All right, so let's start off with the first one. So n is 20, p is 0.6, and I want the probability that x equals 8. Okay, just keep in mind, probability of x equals 8 can also be written as probability of 8. I didn't actually have to write the equal part in there, so I could have just written probability of 8. All right, now the way to find that, according to the rule up above, that's an exact thing. It's a number. So I actually just want to use Binompdf. It's the top one that's still showing up above my window right here. So it's equals exactly 8. So I want to use Binompdf. And then I have to use n, p, and x. Well, n was given to us as 20, p is 0.6, and x, rather simply, is 8. So 20, 0.6, 8. All right, now we have to go find that with our calculator. So let me clear out of here. I need to go to second distribution. The binomial probability distribution function, get it? Probability distribution is letter A. Oops. And now that we see that, we can actually just use alpha. Alpha is the green button, A, and that'll get us to Binompdf. And while I'm at the subject, you can see Binompdf, which is coming, is alpha B, which is you hit the green button, hit the apps button, and there's your letter B. All right, so I'm going to hit A. My trials was 20. That's my n value. My probability of success was 0.6, and my x was 8. Now this is different than what you've had before. Most of the other menu functions we've worked with in the calculator so far, at the very bottom it said calculate and would run it when you pressed calculate. But these distribution functions don't work like that. They actually paste. So you go down to the bottom and you press paste, and it pastes in the values you placed into the Binompdf function, but it hasn't done it, right? The cursor is still blinking over here because you might want to do something else, which we're not going to do on this time. So we're actually just going to press enter again, and it finds the number for us. It's 0.0355. when we round it. There we have it. All right, so now let's do another one. At most 10. All right, so same numbers. I'm keeping n the same. So n equals 20, p is 0.6. And I wanted to get this one in here because at most 10 is actually what the CDF function does standard issue. So if you look here, it's the less than or equal to 10, right? And that's the symbol, the little less than or equal to. And it uses NP and X, just like PDF does. See how they both use NP and X? So I wanted you to see what CDF is. CDF, by definition, is less than or equal to the value you're looking at. So when I have at most 10, what I'm really saying is I want the probability that X is less than or equal to 10. Now keep in mind what that means, right? That means that's the probability that x is 0, 1, 2, up to 10, right? Because all these binomial distributions always start at 0 at the bottom end. If you recall from a page ago, Here, we have them in here, right? Remember how x can be, right, from 0 all the way up to, here it is, x can be from 0 all the way up to the number you're given, right? So in this case, 15 for the coronary bypass ones, right? So 0 is less than or equal to x, which is less than or equal to n. So in our case, it always starts at 0 on that low end. So what I'm really asking is, what's the chances that x is 0, 1, 2, 3, or 4, 5, 6, all the way up to 10? The problem is that to do that with PDF, the one we'd used over here, you'd actually have to find literally the probability of 0, the probability of 1, the probability of 2, the probability of 3, and you'd have to add them all up. Well, that's really annoying. We don't want to do that. So what we're going to do is we're going to make the calculator do it for us with the CDF function. CDF stands for cumulative. So what it does is it adds. So it's going to take your probabilities of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it's going to add up every one of those probabilities and get a number for you. All right, so let's do that. So I'm going to grab the calculator. I'm going to go to distribution. And I want letter B, if you'll recall. It's close to the bottom right there. Letter B, Binom CDF. My trials is 20 still. My probability is 0.6. And I want it to stop at my x value of 10. So I'm going to tell it 10 and paste. Enter. And there I have it. It's 0.2447. And there we have it. So this one on the left for an exact one is PDF, Binompdf, whereas the one over here is a less than or equal to. That's what CDF does. CDF does 0 up until the number you tell it to stop. All right, so let's do another one now. So we want the probability that x is less than 12. Okay, well, if you want less than 12, that means you want x to be less than 12. But that means you want 0 all the way up to 11, right? Because 11 is less than 12, right? You want to stop at a number that's below 12. So that means you're going to be using binomial CDF up to 11. So let me teach you another little trick. So when you have the same values that you want, you can go back to distribution and you could pick alpha B right there, and then a 20.6 and 11. So the alpha B means you don't have to go all the way down with your down arrow all the time to get to the value. So it's 0.4044. So there we have it. Done with that. All right, next, what about greater than? All right, well, greater than's a little bit different because we want to be able to get higher than we are talking about. So all these other ones were equal to or less than. So in order to do greater than, you have to remember that all the probabilities add up to 1. And since they all add up to 1, what you can do is you can subtract from 1 the binomial CDF. So let me write that up 1 second. Okay, so what we're saying is I want greater than 15. So I want 15, 16, 17, 18, 19, 20. Okay, so I could find all of those probabilities, 15, 16, 17, 18, 19, 20, but that's really annoying, right? So what I could do instead is say, okay, well, I want greater than 15, so why don't oops, I don't want 15, I'm sorry. I want 16, 17, right? Because I want greater than 15. 15 is not greater than 15, sorry. So we want 16, 17, 18, 19, 20. So I could find those 4 probabilities. Or I could say, look, I want to find all the way up from 0 to 15. And then I'm just going to take it away from 1, right? This will add all the probabilities for me from 0, 1, 2, 3, 4, the probability of 0, probability of 1, probability of 2, all the way up to the probability of 15. It'll add them all up for me. And then I know all the probabilities for the whole experiment have to add up to 1. So if I just subtract this bit away from 1, I'll have it. So let me do that. And here's another fun fact. You can actually do it all at once. That's why it's a paste instead of a calculate on those distribution menus. So you can type 1 minus second distribution, pick alpha B, which is binom CDF, and you can tell at the top it'll say binom CDF. That's, always double check yourself that you've done the correct one. And we want 15 this time. Paste, enter. And there we have it. It figured it out. It's 1 minus 0.9491 or so, and then you take it away from 1, it's 0.0509. Now, if you wanted to, you could have done the binom CDF part on its own, right? You can just do this portion and paste it, and then say to yourself, okay, it's 1 minus 0.9490, and then subtract. So that's possible as well. So if you want to do it in 2 parts, you can. Or if you want to do it in 1 part, that's okay too. So I just typed that up in the worksheet. Here, let me just close that. There we have it. So it's 1 minus 0.9490. And when you round it, it's a little tricky rounding because 0.05095, if you want 4 decimal places, the 5 will round the 9 up to a 10, right? So it becomes 0.0510. All right, so that was completely divorced of context, right? We're just thinking about the numbers, and what we know about x is that it has to be between 0 and n, which in this case was 20. So now let's give it a little bit of context. Suppose you have a random family and it has 4 children, and you want to find the probability distribution for that random variable, where x is the number of boys for the family. If you assume there's 2 equally likely genders, so we're going to assume 50-50, and there's only 2, which of course both are actually incorrect in the real world, but that's the way we're going to work it. All right, now where have you seen this problem before? Well, we saw it back in section 6.1. Let me scroll back to that real quick. Right here, we used it for an expected value question right here. So we can see the numbers and the answers, but I'm going to prove it to you that it's these values. And I wrote right here, we're going to learn how to find them quickly and easily in section 6.2. Now is the time. We're going to do that. Let me go back to 6.2. When I saw the probabilities were these values, but now let me prove it to you. So for this problem, this is binomial, right? Binomial experiment. And n is 4, right, because there's 4 children, and the probability of success, because we assume 50-50 for only 2 genders, right, the whole equally likely 2 gender thing, that's what makes it so that it's 0.5 for our probability of success. So now we want the probability of exactly 0 boys, the probability of exactly 1, right? That's what we're looking for here. So we're looking for the probability of 0 equals the probability of 1. I mean, that's what this is a table for. We don't write this all the time, but that's what you're finding when you do this, right? So if that's the case, that means we want an equals. That means we want Binompdf. So let me go grab the calculator. Now remember that n was 4 and p was 0.5. Now notice at the top I used Binompdf. I got that by hitting alpha A because I knew it was A. And now we're going to do something crafty here. We're actually not going to put in an x value. I know it's kind of freaky, but that's what we're going to do. We're going to leave it blank. You can do that. The x value is not mandatory. You have to put in an n and a p every time, but x value is not always required. All right, so it comes out Binompdf 4, 0.5. Let me press enter, and that's the values I get. And now sometimes, I'll be honest, they're really long, and so then you have to hit the left and right arrows to kind of scroll through them, but these ones are so short you don't need to hit the left and right arrows. Now, if you find this difficult to look at, or if there's more values here than you can see on the screen, what you can do is you can hit the store button. It's STO with a little arrow after it. It'll take that last result and it'll store it. And the place to store a list like this is in a list. So I'm going to store it in L2 for myself. Enter. And it'll just show me the list again. That's fine. But if I go to Stat Edit, I can see the list of values right there. See them in L2? And then I could type for myself 0, 1, 2, 3, 4. And I can see there's the table that we're looking at, right? And remember, the x values always start at 0 and end at whatever your n was. In our case, our n was 4, so that's where we stopped. So there they are. So let me type up what I did. And there we have it. We found all of our probability values. Now, granted you, we don't usually put probability of 0, probability of 1. I just wanted to get you guys to see that that's why it works out that way. Because when you're finding the probability, what you're finding is the probability that x equals some number, right? Here, little number. That's what you're looking for when you do this, right? So because it works out that way, then it's going to be PDF every time for all of these. So the actual answers are really just the number parts. All right, we're all done with that one. I'll see you back here for more tutorials.